Have you ever wondered what happens when someone falls overboard from a ship, but nobody notices 4 hours? This is a delayed man overboard, or MOB, situation, and it's one of the most challenging emergencies at sea. Unlike an immediate MOB, where a rescue can be launched right away, a delayed discovery creates a whole new level of complexity. The person in the water is alone, unseen, and every second that passes stacks the odds against them. Today, we're diving deep into the grim realities of a delayed MOB. We'll explore the critical factors that determine survival and the immense operational hurdles rescuers face when the alarm is finally raised. This isn't just about throwing a lifebuoy. It's a race against time, tide, and temperature. By the end of this video, you'll have a profound respect for the protocols and technology designed to tackle this maritime nightmare. So, what are the primary threats to a person in the water? The first and most immediate is cold shock. The moment someone hits cold water, their body involuntarily gasps for air. If their head is underwater, this can lead to immediate drowning. Even if they survive this initial shock, their body starts losing heat rapidly. This is hypothermia. As their core temperature drops, they become confused, their muscles weaken, and eventually, they lose consciousness. The colder the water, the faster this happens. In near-freezing seas, survival time can be measured in minutes, not hours. Then there's exhaustion. Treading water, especially in rough seas, burns an incredible amount of energy. Without something to hold on to, even the strongest swimmer will eventually tire and be unable to keep their head above water. This is why a life jacket is arguably the single most important piece of survival equipment. A properly worn life jacket keeps a person's airway clear of the water, even if they're unconscious from hypothermia or exhaustion. It conserves precious energy and dramatically extends their survival window. It turns an impossible fight into a waiting game. Another critical factor is visibility. Finding a single head bobbing in the vastness of the ocean is like finding a needle in a haystack. During the day, with good weather, it's difficult enough. At night, or in fog or a heavy rain, it becomes nearly impossible without help. This is where personal locator beacons, or PLBS, and strobe lights attached to life jackets become lifesavers. A simple flashing light can be seen 4 miles at night, turning an invisible victim into a beacon of hope for search crews. Similarly, smoke flares or dye markers can increase a person's visibility during the day. Without these aids, the chances of being spotted are tragically slim. Now, let's talk about drift. A person in the water doesn't stay put. They are at the mercy of the elements. The ocean current will carry them in one direction, while the wind pushes them in another. This combined movement is known as drift. The wind's effect, called leeway, is particularly complex. It depends on what the person is wearing. Someone in a bulky life jacket will be pushed by the wind differently than someone with no flotation at all. Understanding and predicting this drift is the key to a successful search, and it's one of the biggest challenges in a delayed MOB. Let's shift our focus to the operational side. Imagine you're the captain of a large ship. You get a report that a crew member is missing. Their last confirmed sighting was 6 hours ago. In those 6 hours, your vessel, traveling at 15 knots, has covered 90 nautical miles. That's over 100 regular miles. The person could be anywhere within a massive, ever-expanding area of the ocean. The last seen position, or LSP, is no longer a precise point. It's a vague memory from hours ago. This is the fundamental problem of a delayed MOB. You don't know where to start looking. The first step for the ship's crew is to retrace their route. They'll turn the vessel around and head back along their previous track. But this takes time. A large container ship, tanker, can take several miles just to complete a turn. While this is happening, the search and rescue coordinators on shore are already at work. They can't just guess where the person might be. They need to calculate a probable search area, and this requires sophisticated modeling. This is where tools like SAR drift models come into play. These are computer programs that take all the known variables, the last seen position, the time elapsed, the ocean currents in that specific area, and the wind data and run complex calculations. They use things like leeway drift tables, which provide data on how different objects, including a person in the water, are pushed by the wind. More advanced systems like OSCAR, which stands for Ocean Search and Collision Analysis, or the Search and Rescue Optimal Planning System, SEROPS, used by the US Coast Guard, can create highly detailed probability maps. These maps show rescuers the most likely areas to find the missing person, allowing them to concentrate their efforts where they have the highest chance of success. Even with these powerful tools, the search area can still be enormous, often hundreds of square miles. A single ship searching such a vast area is simply not effective enough. This is why a delayed mob almost always escalates into a major search and rescue operation involving external assets. The ship's crew becomes just one part of a much larger team. The Rescue Coordination Center will likely dispatch dedicated SAR resources. Coast Guard cutters or naval vessels are often tasked to the scene. These ships are equipped with advanced search equipment and trained crews. More importantly, they can deploy helicopters and fixed-wing aircraft. From the air, the view is much better. A helicopter can systematically search large areas much faster than a ship. They're equipped with high-powered optics, infrared cameras that can detect a person's body heat against the cold water, and powerful searchlights for night operations. A helicopter can also perform the rescue itself, hoisting the person directly from the water, which is often safer and faster than a ship-based recovery in rough seas. The coordination of all these different assets, the original ship, Coast Guard vessels, aircraft, is a monumental task. Everyone needs to communicate on the same frequencies, follow a coordinated search pattern, and constantly update each other and the onshore coordinators. Each piece of the puzzle, from the drift calculations to the unseen searching, must work in perfect harmony. In summary, a delayed MOP is a multifaceted crisis. For the individual, it's a desperate battle against the elements, where survival hinges on flotation, visibility, and the unforgiving clock of hypothermia. For the rescuers, it's a complex problem of detection and logistics, starting with an uncertain location and expanding into a massive, coordinated effort against the vastness of the ocean. The technology has improved, with advanced drift models and aerial assets, but the fundamental challenge remains. It highlights the absolute importance of preventative measures on board ships, proper safety procedures, mandatory use of personal protective equipment like life jackets, and technologies that can automatically detect when someone goes overboard. Because in a delayed MOP, the best rescue is the one you never have to launch. Thanks for watching. Understanding these challenges gives us a greater appreciation for the brave men and women of search and rescue services worldwide and the incredible work they do. If you found this informative, please give it a like and subscribe for more deep dives into the world of maritime operations. Stay safe out there.